Hello, ladies and gentlemen, and welcome to another pre-calculus for business lesson with Professor Checo. Today's lesson is going to be 4.3. It is going to be based on Gauss-Jordan elimination. Let's get started. I didn't need to print. I want to print preview. Preview. All right, so it looks like we have 27 questions. Let's get straight to the textbook. Get more help, textbook. All right, so last lesson homework, we were focusing on matrix and how matrix are, and kind of like the operation and basic with matrices. Well, when my textbook loads, here we go. So, Gauss-Jordan elimination. So now that you have some experience with row rep operations on simple augmented matrices, we consider systems involving two or more variables. We will not require systems to have the same number of equations. So basically here, there are three solutions. There are three possible solutions. Exactly one solution, infinite many solutions, and no solution. So a reduced matrix will look like from all these numbers to the next page, where it will look like this, a diagonal, this form 2, or this form 3. This is one solution. This one would have infinitely many solutions, and this one would have no solution. So reduced form. Each row, a matrix is said to be in reduced row echelon form, or more simply in reduced form, if each row consisting entirely of zeros is below any row having at least one non-zero element. So here, boom, all zeros. The leftmost non-zero element in each row is 1. All other elements in the column containing the leftmost one of a given row are zeros, and the leftmost one is to the right of the leftmost one in the row above. Here's the 1, 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 here's the 1. Here's the 1, here's the 1, here's a 0. So this one would have infinitely many solutions because of the second variable having that, and this one has no solution. So just be careful because they are still reduced. And what does it say? The following matrices are reduced form. Okay, reduced form, but I just meant this one has no solution. It's still reduced. Moving on. All right, here we go. Where all the conditions are violated. Nah, I'm not really saying here. I'm gonna move on. All right, so what is this? This is just using matrix operation to do redo. All right, procedure: Gauss-Jordan elimination. Choose the leftmost non-zero column and use the appropriate row operation to get the 1 in the top. Yeah, so basically, like if you look at this, you're gonna want to put row 3 in the first row so that it starts with a 1. Then you're gonna want to multiply. You need a 0, so you multiply it by 3, add it to there. You need a 1 there, you multiply. And it is a lot of just work, and you follow it, guys. Just follow the steps. It's all there. It's all laid out. Yep. Repeat, repeat, repeat. Read that. It's all there. And this is how to do it by hand. And then it's going to go into more by hand, and more by hand, and more by hand, and more by hand. So like, cool. More by hand, and that's the end. So let's go and take a look. So here, write the augmented, write augmented the matrix and corresponding to the following system of linear equations. So what is this? This is going to be a 1, 2, 3, 4, 4 by 2. So this would be 8, 2, 8, 6, 3, 3, 1, negative 9, 9. Done. Moving on, write the equation. Which one is the first row? Boom. Easy. So that's going to be, what are the variables am I using? x1, x2. So x subscript 1 minus 5x subscript 2 is equal to 2. What's the second row? And then the third row. Easy. Here, which one corresponds to the first row? Which one corresponds to the second row? Which one corresponds to the third row? Easy. This matrix is reduced form 0, 1, 1, 0, 0, 1. Which row operations necessary to perform the matrix into no rows are necessary. It's already in reduced form. Here, this one is not in reduced row echelon form. So we need to switch row 3 and row 1 because this 1 needs to go up there. Alright, this one is not. The next step is to multiply row 2 by 4, negative 4, so that we subtract it. So here, 1, 0, 1, 1, 1, boom. This one has a unique solution. X1 is equal to negative 3, x2 is equal to 9, and x3 is equal to 0. Here, so we have 0 equals 0, so this means that there's going to be infinite number of solutions. So this one has infinite number of solutions. This one is going to be x1 equals 4 plus 70. And this one is negative 6 minus t, because you're rewriting it and substituting it in. All right, so here, boom, boom, no solution because 0 does not equal 9. Which of the following reduced augmented matrices is the number of leftmost ones equal to the number of variables? Boom, boom, boom. A is good. Not B, not C, not D, and not E. Which of the following reduced augmented matrices is the number of ones less than the number of variables? So that's equal to 1, 2, that's less than, that's B. 1, 2, that has no solution, so this one is 1, 2, that one has, that's D and E. Discuss the validity of the following statement about linear systems. If the number of leftmost ones is equal to the number of variables, then the system has exactly one solution. Let's go with this one. What counterexample is that? Because 0 equals 1 means no solution. If there is a all 0 row, then the system has infinitely many solutions. I think that is... I'm not even sure this is a definition. The statement is not always true. For example, a row of all zeros in a reduced row of form of augmented matrix with fewer rows and columns I think it's this one. No, try again. It was A. For example, a single row of all zeros in the reduced row of augmented is with the same number of rows as columns means that the sum of the information given from the equation was redundant. The system has a unique there. Okay. I mean, I'm trying to think of a counterexample, guys. Like, this is literally just not always true. I don't know what to do there. All right, let's just fill in the blank. So that's 5, 0, 3. Okay, so now let's think about this. They want us to do this times 4, right? So this times 5, that's 15. 0 minus 15 is negative 15. Oh, that's going to be a 0 then. I'm sorry. There you go. Use row operations to change the matrix to reduce form. All right. Now, this is going to take a little bit of work. Obviously, I can multiply this by 2 and subtract row 2 by that. But I'm going to show you my little friend Desmos. Now, obviously, Desmos is a graphing calculator. But if you click on the logo and go to a matrix, ooh, I can now do a new matrix, which will have 1, 2, 3, 4. And then if I do 1, 1, 1, 13, 2, 3, 9, 34, and hit enter, RREFA equals 1, 0, -6, 5, 0, 1, 7, 8. Check answer. Beautiful. Here, this is a 1, 2, 3, 4. This is a 3 by 4. So new matrix. This is a 3 by 4, and then literally the same exact thing, guys. And then you just reduce form it. You do 1, 0, -5, 1, 1, 4, 2, -8, enter, and then RREF, B, enter, and that gives me 1, 1, 1, -4, 16, and -19. Everything else gets zeros. Yep, it's that easy. Okay. And now 1, 2, 3, 4. I could do like just clear, and then literally, guys, 1, 2, 3. This is a 3 by 4, 3 rows, 4 columns. You hit enter. You could go into whatever equation, however you want to do it. 2, 6, -17, and 19, followed by 4, 36, -98, and then 142. This one is 1, this one is 7, this one is -19, and then this one is 27. Enter. If I do RREF of A, hit enter, my solution is -3, 7, and 1. Like, it doesn't get any easier than that, guys. Literally the same exact thing. Same exact thing. So once you get it, they want you to just plug it into the augmented there. So like you're just doing the same exact thing over and over. Just plug it into the matrix calculator, RREF it, and that will give you all the answers. Solve using Gauss-Jordan Elimination. This is a 2 by 1, 2, 3, 4. New matrix, 2 by 4. This is going to be 4, 16, tab, -8, tab 8, then 2, 8, -4, and 4. Hit enter, RREF of B, hit enter. Write the system. Okay. So now if you notice here they gave me a 4, but here I have a 1. So what do? I multiply this by 4. 4, 16, -8, and then last answer 8, with all of these being 0. At least one of your answers is incorrect. 2, 16, -8, 8. 2, 8, -4, 4. Write the system as an augmented. Oh, just annoying. 2, 8, -4, and 4. And then go ahead and solve it. So the system has infinite many solutions where x1 equals 2 minus 4s, and then what is that, plus 2t, plus 2t. Cool. Same exact thing. Same exact thing. So different. Okay, so let's look at this one. Find A, B, and C. So the graph of the quadratic y equals ax squared plus bx plus c passes through the point boom, boom, and boom. Huh. How do they view this? How do they do this one? 5a minus. Oh, I get it. We gotta find the numbers A, B, C. Okay. I get it. 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 So I'm gonna just clear this new matrix. So I have three equations, right? So this is gonna be a 3-row by A, B, C, 4. The first equation, if I plug in -3, that's 9x. Oops, 9x minus 3, and then plus 3 plus c would be 1 equals 27. And there's the first equation. Second equation is going to be 1a plus 1b plus 1c equals -9. And last but not least, we have 3 squared is 9. 3 and 1. Yeah. And then enter, and if I hit, oops, this should have been -3. So then what is RREF of A? What is the function? Y equals 2x squared minus 5x minus 6. Cool. Alright, let's see. A dietitian in a hospital is to arrange a special diet composed of 3 basic foods. Constructive mathematical. Alright, so obviously, let's change this. This is going to be 20. This is going to be 10. This is going to be 10. And then this is going to be how many? You need 100 units. This one's going to be 10. This one's going to be 10. This one's going to be 10. And how many do you need? You need 80 units of iron. And then how many do I need here? 10. How many do I need here? 20. How many do I need here? 30. And then how many do I need? 160 of vitamin A. So is this not what I literally just typed? 20, 10, 10, 100. Can I just hit enter? Can I do 10 and tab at 10, tab, 10, tab, 80, tab, 10, 20, 30, tab, 160. And then how many ounces? 2 of A, 5.9. How many? Type whole numbers. So 6 ounces, and then 0. How many ounces of each food must be used to meet the diet requirement? Therefore, the diet requires 2 ounces of food. All right, wait. This gives me 6, 7, 8. So this gives me a total of 8. 8, 8, 8, 8. 240 times 3 times 3. Multiply this by 3, which gives me 6. 6 times 3 is 18, and then 0.71 I don't know. Where am I? What's wrong? 242. That's not what I got. Oh my god, I put 301. That's 30. Jime. And there it is, 242. Cool. All right, how is the diet in part A affected if C is not used? Select the correct answer. If C is not used, so that means that like that would there are no solutions if you don't eat food C, because you get 0 equals 1. You won't be able to get whatever it is. All right, how is the diet in A affected by the vitamin A requirement is dropped? What was this? This was 10, 10, 30? Yeah. How is the diet in part A affected if the vitamin A requirement is dropped? Vitamin A, so let's say that we only need like 100. There are multiple solutions. If the diet uses T ounces of C, it should be I mean if this equals 0, there's still one solution that requires 2, 20, and negative 14. It's not negative 3, negative 14. Change the system of equations. What did I not change? View an example. I'm a part C. Oh my god, 33 parts? Jeez, you have to do it all by hand. There's B. Where's C? How is the diet changed? So recall the model from part A. Remove the third equation to reflect the vitamin A requirement is dropped. Oh, remove the entire equation. Okay, so then I need a new matrix. I need it to be a 2 by 4. And then it's going to be 20, 10, 10, 10, 10, and 100. And then this is going to be 10. This is 10. This one's going to be 20. This one's going to be 30. And then this one is going to be 10, 10, and 10, and then 80. 80. Enter RREF, B, enter. So it seems that we will have, there are multiple solutions. If the diet uses T ounces of food C, it should use 2T ounces of 2T food A, and then what is that? Oh no, 6 minus T. No, it should use 2 ounces because x1 is equal to 2, and it should use 6 minus T where it's satisfying 0, and I don't know what that number is going to be. 10? I have no idea what that number is going to be. 2, negative T plus 6, 0 to 6. Why did it go to 6? Oh, because then 6 plus 6 gives you 0, and then you would be negatively deficient in B, which is iron. Okay, that makes sense. Because then it would be negative. I get it. Moving on. Alright, so a farmer can buy 4 types of plant food. Each barrel 40. Alright, I'm going to clear all. Let's go with a new matrix. The new matrix is going to be a 1, 2, 3, 4. So it's A, B, C, D, and then the solution. So there should be 4 rows, 5 columns, right? Each barrel of mix A contains 40 pounds of phosphorus, 50 pounds of nitrogen, and 20 pounds of potash. One, two, three, four. I think it's a 4 by 4. Bag B contains 40 pounds, 75 pounds, 30 pounds. Stash C contains 40 pounds, 25 pounds, and 30 pounds. And D contains 80 pounds, followed by 25 pounds of nitrogen, followed by 50 pounds of. Okay, soil tests indicated that a particular field needs 1,640 pounds of phosphorus acid. Let me just see how they're setting it up. Numbers of barrel mix A, yep. 40. Oh, they did it the other way. Oh, dang. Clear. This is a 4 by 3 new matrix 3 by 4 where it's 50 pounds, oh no, 40 pounds, I gotta do this properly, 40 pounds of phosphoric, 50 pounds of nitrogen, and 20 pounds of that, followed by 40 pounds of phosphorus, 75 pounds of nitrogen, and 30 pounds of that. C contains 40 pounds, 25 pounds, and then 30 pounds. Column there is going to be D is 80 pounds, followed by 25 pounds, followed by 50 pounds, and then I need a total of 40 pounds of phosphorus, 1100 pounds of nitrogen, and 1100 pounds of potash. And then I'm going to do RREF A and hit enter. How many pounds do I need? There's going to be this solution, which is I need 13 minus, using t as a variable, x4 is equal to t, so 13 minus t. This is going to be negative 5 plus t. This is going to be 33 minus 2t, where t goes from 0 to 11, because that would be negative. No, so what makes that negative? From 5 to 11, right? 5 to 11, because that makes that negative. Oh, I gotta be so close. Oh, 33. Dang it. 33 minus 2t. Okay. So that's 12. I think I go up to 12. Because 12 times 2 is 24. 13 gives me 0. I think I can maybe go up to 13. Yeah, I can go up to 13. Nice. Check mark. Awesome. All right, last question. Two sociologists have grant money to study the school busing in a particular city. They wish to conduct a study using 637 phone contacts and 498 house contacts. Survey company A personnel to do. How many hours should be scheduled for the firm to find them? Okay, so let's do a new matrix. This is going to be a 2 by 3. 2 rows, 3 columns, where it's going to be 32 phones and 11 houses. And then they can handle 20 phones and 16 houses. We have 637 phones and 498 houses. Enter RREF, that bad boy, which gives me the nearest hundredth, so 0.79 hours, and then they should do 30.58 hours for homes. Done. Ladies and gentlemen, that is 4.3 Gauss-Jordan Elimination using the Desmos matrix calculator. Not too bad. Best of luck. See you next time.